So, in this lecture we shall sketch a proof of the fact that GLN R plus, so this is those n cross n matrices, says that determinant of A is positive, is path connected. So, we shall see this as an application of whatever we have done so far, and okay, so let us denote. So, denote G by this GL and R plus. Okay, so we will do this. So, first of all, it suffices to show, to connect, to show that any matrix A in G can be connected to the identity by a path in G, right. So, we have our G over here. So, given any matrix A, we can connect it to identity, right, using a path. So, that is what we are going to prove, and we will do it in several steps. So, let us begin. So, let A be in G, right. So, then the first step is then we can join A to B in G. So, when we say join A to B in G, we always mean join by a path which is completely contained inside G, right. So, where B is such that B11, the first entry is non-zero, yeah. So, this B11, that should be non-zero. Okay. So, how do we do this? So, if A11 is non-zero, then we just take to be the constant path, right. So, gamma of t is equal to A. So, the constant path is continuous, and therefore, we can just take B to be equal to A, right. So, on the other hand, if A11 is equal to 0, so then since G is an open subset of MNR, right, and MNR has the product topology, there exists an epsilon positive such that the set U, this is those B in MNR with the absolute value of Aij minus the absolute minus Bij is strictly less than epsilon for all I comma j, right. So, this is going to be contained in GLN, this G, right, simply because GLNR plus is open inside MNR, yeah, and okay, so we can, for instance, and MNR has a standard topology or product topology, or yeah, so we can see this in many ways. Okay, so we just take any B in U with B11 not equal to 0. Okay, then take the path gamma from 0 1 to u given by gamma of t is equal to t times a plus 1 minus t times b. Okay. So, this path is going to be completely contained inside u because each coordinate of gamma t I j, right. So, this is a I j and this b I j. So, the distance between them is less than epsilon. So, for any t, gamma t I j is going to be over here, somewhere in between a I j and b I j. So, the distance of that from a I j is going to be less than epsilon. So, it is going to be contained inside u, which is contained inside g, right. So, this implies that. So, this gives the required step 1, right. So, we have joined A using a path to this matrix B and B11 is non-zero. Okay, so let us go to step 2. If B is in G and B11 is non-zero, so recall this EIJs, these are the elementary matrices. So, these are matrices of the type okay, so instead of EIJ, right. So, right. So, then there exists a matrix E1 of the type 1, these entries are something, and on the diagonal we have 1 and all these are 0. Yeah. So, there is a matrix of this type such that E1, when we multiply it on the left by B, all these except for the first one, all the other entries in the first column become 0. Okay. Okay, so this first one is going to be lambda. So, let us assume that B11 is lambda. Okay. So, similarly, there exists a matrix E2, right, of the type 1. So, the first row is of this type and in the diagonal we have 1s and all the other entries are 0, right, such that E1 B E2 is of this type. So, lambda, all the other entries in the first row are 0, all the other entries in the first column are 0, and here we have a matrix D. Okay. So, we consider this map. Uh, 0 1 is GL and R plus, which is given as follows. So, T goes to 1 minus T times identity plus T times E1 into B into 1 minus T times identity plus T times E2. Okay. So, we need to check that first, as a map of sets, the image actually lands inside GL and R plus, but when we take determinant for each T, let us look at this matrix. One minus T times identity plus T times E11, E1, right. So, E1 is a matrix of this type. So, one easily checks that once again this is going to be a matrix of this type. Right. So, this implies determinant of this matrix is equal to 1. Okay. So, similarly, determinant of 1 minus t plus te2 is going to be 1. So, this matrix is now going to be of this type, here 0, and the first is going to be of the same type as E2. Okay? So, this implies that determinant of gamma of t is actually equal to determinant of B, which we know is positive. Yeah. So, therefore, as a map of sets, indeed the image of gamma lies inside GL and R plus. Next, we want to check it is continuous, yeah, but gamma, to check gamma is continuous, we can just, since GL and R plus is contained in M and R and has a subspace topology, it suffices to check that the coordinates of gamma are continuous. Right? But the coordinates of gamma are polynomials, but these coordinates are polynomials in T, yeah, and so are continuous. That's easily checked. When we multiply out these matrices, these three matrices, right, it's clear that the coordinates will be polynomials in T, and so gamma is continuous, since each coordinate function is continuous. Right? So, we have this path from 0 1 to GL and R plus. Now, gamma of 0 is equal to, we can check it's equal easily, it's equal to B, and gamma of 1 is equal to E1 B E2, which we know is a matrix of this type, B. Okay, so this completes step 2. So, this completes step 2, right. So, if B is a matrix such that B11 is not 0, then B can be connected to a matrix of this type. Okay, so let's go to step 3. So, if lambda is positive, then this matrix lambda zeros D so let's look at this path. So, maybe so consider C to be equal to lambda all these zeros, right. So, then and let lambda be positive, right. So, then C can be joined to one and a map matrix D prime, right. Okay, so obviously this is in G, yeah. So, we are starting with some matrix C in G of this type, then we can join it to some D prime like this, yeah, where D prime belongs to GL n minus 1 R plus. So, how do we do that? So, we look at this path. So, we look at this matrix. So, T times lambda inverse plus 1 minus T. So, this is the diagonal matrix. So, in A11 it has this entry, and in all the other diagonal entries it has 1, right. So, what is this? What happens over here at this entry? So, this is joining. So lambda is positive, so lambda inverse lies over here, and let's say 1 is over here. So then this is the straight line joining 1 with lambda inverse. So and we just multiply this with C. Okay. So when we take determinant, so let's just once again we check that when we take this is equal to gamma of t. So determinant of gamma of t is equal to t times lambda inverse plus 1 minus t into determinant of C, which is therefore positive. So therefore the image of gamma actually lands inside GL and R plus, and once again this is continuous because each of the coordinate functions are polynomials in t, in the variable t, right. So and notice that gamma of 0 is equal to C, and gamma of 1 is so lambda inverse 1 times C, which is lambda t, right. So this is equal to 1 0 t. This is in GL plus. Okay. So if similarly if lambda is strictly less than 0, then this path t times mod lambda inverse plus 1 minus t 1 1 times C connects C with minus 1, a matrix of this type, right. Say let's say some D prime. So now we want to show that this matrix D prime can be connected to a matrix of the form 1 D prime prime. So this is in G, and we want to connect this to in G, right, via a path in G. So for this, let us check that. So consider this matrix T times minus 1, this 2 cross 2 matrix. This is equal to minus T and this has determinant t square plus 1 minus t whole square, which is positive, right. And similarly t times this matrix plus 1 minus t times 0 1 has determinant positive, right. So what this means is that this minus 1 can be joined to 1 comma 1 in GL2 R plus, right. So in fact this first thing, that's a path from 0 1, okay, that's a path joining minus 1 to 0 1 minus 1 0 in this path is completely contained inside GL2 R plus, right. And similarly there is a path completely contained inside GL2 R plus which joins this matrix to 1 1 0 0, the identity, right. So therefore this minus identity can be joined to identity in GL2 using a path inside GL2 R plus. right? So we will use this by a path. So there exists such a path because we can just put these two paths together, as we had seen when we proved that when we defined path equivalence classes. Okay, so now we define a map from gamma to 0, from 0, 1, using this gamma, okay, let's say gamma tilde, to GL and R plus by gamma 1, 1 t, gamma 1, 2 t, gamma 2, 1 t, gamma 2, 2 t, and here all zeros, here identity, and 0 over here, right? So clearly this path joins minus 1, 1, 2, 1, 1 to the identity in GL and R plus, right? So then the path from 0, 1 to GL and R plus, given by t goes to, okay, so this path is what we are calling gamma tilde t. So gamma tilde t times this minus 1 d prime, right? So it joins minus 1 d prime to 1 prime prime, let's say. Okay. So thus we conclude that if C in GL and R plus is of the type lambda, it's a block matrix, is of this type, yeah. So then C can be joined by a path in GL and R plus to a matrix 2 of the type one d prime prime, right? And then d prime prime is forced to be in GL n minus 1 R plus, right? So now, so what have we done so far? We started with the matrix A, we connected it by a path to a matrix B such that B11 is not equal to 0. Then we connected it to a matrix C such that C is of this type D, right? So then we connected this to a matrix of the type 1 D prime prime, right? So by induction on N, we may assume that d prime prime can be connected to identity n minus 1 in GL and R plus, in GL using a path gamma, right? So then the path 1 0, so gamma of t in GL and R plus connects d prime prime to the identity, right? So we have this path is connecting to this, right? Thus we have proved this is only a sketch, and I will leave it as an exercise to fill in the details and convince yourself that all the arguments are correct. Every element A in GL and R plus can be connected using a continuous path gamma from 0 1 to GL and R plus to the identity. So this proves that GL and R plus is connected, is path connected, and in fact connected, because we know that path connected spaces are connected. So we will end this lecture here.